The plan for this lesson is to discuss data reduction methods. We will cover regression methods, grouping-based methods like clustering and histograms, data cubes, aggregation, and data compression. The size of the data we are able to collect in today's technologies keeps on growing and growing in size and number of dimensions. For example, in the machine learning and AI communities, working with millions or billions of dimensions is normal. So it does make sense to find ways to reduce the data size and dimensions so analysis can run in feasible time and resources. There are several methods to perform data reduction. Regression in all of its form, whether it's linear or log linear, statistical and grouping methods like histograms, clustering, and sampling, data aggregate methods like data cubes, data compression. Reduction methods can be parametric or non-parametric. On the parametric side, the method assumes that the data fits some model like in regression. Given a dataset, we estimate the model parameters, store only those parameters, and discard the data, maybe with the exception of the outliers. On the other hand, non-parametric methods do not make assumptions about the models or the data or the distribution, and some of the examples are histograms, clustering, and sampling. The first data reduction method that we will discuss is regression. Let's start with a motivational example. Suppose we have collected data about how much tips people pay when they eat in a restaurant, and the data was collected for Thursday, Friday, Saturday, and Sunday. However, this data is so huge and we don't want to keep it around. So we're only interested in summarizing or modeling this data as a formula. So we can apply it to the parameters and predict the value of the tip. Regression is a collective name for techniques for modeling and analysis of numerical data. And in regression, we work with two types of variables: a dependent variable, or the response, the variable that we're trying to predict here, which is the tip, and one or more independent variables or predictors that we use in the prediction process. And here is the formula. The observed value, tip or y, or the response, is a function of two unknowns: w for the slope, b for the bias, plus some noise we need to capture in the model, and very often we use a normal distribution to capture the noise. And what goes under the hood in regression is finding the parameters that are going to give the best fit line given a criteria like least squares method or mean square error. Nonlinear regression is when the data are modeled by a function which is nonlinear, something like log linear. And multiple regression when the data is multidimensional. So the response variable y modeled as a linear function of multidimensional vector space. Moving to the non-parametric methods, histograms divide the data into buckets and only store representatives to these buckets, like the mean or the median. Some of the partitioning rules are the equal width or the equal frequency, and as you can see in the visualization, equal width, each bucket should have the same range, and equal frequency, we're looking at the same depth. Clustering is a partitioning technique where the data is going to be partitioned into groups based on the similarity. So the members of one group are similar together and dissimilar from other groups. And instead of storing the whole data, we only store representatives of each cluster or each group, something like the centroid or the diameter. And some of the methods we use in clustering, the hierarchical clustering, or maybe something simpler like using a multidimensional index tree data structure. Sampling is another non-parametric data reduction method. So what happens here, we obtain a small sample to represent the whole dataset. But the key here, we want to find this representative subset of data, because simple random sampling will for sure end up with poor performance, because we can't guarantee that the whole dataset got presented inside the sample. Some of the adaptive sampling methods to address this issue is stratified sampling. More on sampling, so simple random sampling, there's an equal probability of selecting any item in the dataset. Sampling without replacement, so once the item is selected, it's removed from the dataset, so it doesn't get selected twice. But sampling with replacement is the opposite. We draw and put back in the dataset, so any item can be selected more than once. Stratified sampling tries to solve the issue of ensuring that the sample is representative. So first, the dataset is partitioned, then we draw from each partition, so we guarantee the sampling. So suppose that we want to select a sample of 100 students from the university, so it's good to create partitions based on the colleges or the majors, and then do the sampling so we make sure that the dataset is as representative as it can be. Data cubes are multidimensional arrays of values that uses multiple levels of aggregation to reduce the data and allow efficient data processing in the data warehousing environment. Data compression is another data reduction technique. For the strings case, it's lossless. We can compress and decompress text without issues. But audio and video compression, it can be lossy. But the key here is only losing a few number of frames without affecting the overall quality of the video. In summary, we discussed data reduction methods, regression, grouping-based methods like histograms, clustering and sampling, data aggregation, and data compression.